Alright, our next triangle center is what we call the centroid, and this one is probably my favorite of the four we're going to talk about. There's some very, very cool things going on here, and with the other two triangle centers that we've talked about so far, I discussed their meaning first. I'm going to save the meaning for this one for last because it's kind of like a treat for me, so I'm going to save it and enjoy it. The centroid is made from taking a specific kind of line and from each one of the vertices of the triangle and finding where they all meet. So let's talk about that line first. Imagine taking a line and drawing it through the vertex of one of the angles to the midpoint of the opposite side. So that is, the opposite side is cut into two equal pieces. It's almost like a perpendicular bisector, but without the perpendicular part, and this has to pass through the vertex of the other angle, or the angle across from it, I should say. So again, we've got a line that goes from the vertex to the midpoint of the opposite segment, and this particular line is called a median. So again, a median is a line connecting the vertex of a triangle to the midpoint of the opposite side. So if I take these and I draw all three medians, so there's the median for another side and the median for the third side, they meet at this one point in the middle, which you can see with the black dot there, and that point is called the centroid. So the centroid is just the point of concurrency for the medians of a triangle. It's the point where all three medians run into each other. And now let's talk about some of the properties of this. First, that centroid, that spot here in the middle, divides the triangle into 6 equal triangles. So if we take a look at this, we've got 1, 2, 3, 4, 5, and 6 triangles this is broken down into. And each one of those triangles has an equal area. So that is, if I were to take a can of paint and I want to paint this triangle right here, it would require the exact same amount of paint to paint this triangle, and this triangle, and this triangle, and this triangle, and this triangle. And this leads us to something incredibly cool. If we have this triangle being a physical triangle, like it's actually made of something, it's something I can hold in my hand, and it's uniform, like it's the same thickness throughout, and it's made of the same material throughout, each one of these triangles, because it has the same area, is going to have the same weight. That means that all points around the centroid are going to have the same weight, and the triangle is going to balance itself out at the centroid. So imagine I took this and I physically have this triangle in my hand. I could turn it sideways where it's laying flat like this, and if I were to put my finger on the centroid and just let go, the triangle would balance there perfectly. We call this the center of mass of the triangle. So again, the centroid is the center of mass, so that's the point at which it acts like all the mass of the triangle is there, and it's sort of the balancing point for it. So you can imagine, I don't know if you've ever seen somebody spin a basketball on their finger and have that spin around there and how it balances right at that one point. Like if you were to try and move that over to the side, it's not going to work quite as well. The balancing point for a triangle is the centroid. Or indeed, you can generalize that to any figure and call the center of mass the centroid. But we're going to focus on triangles here. This is also called the barycenter. You're not going to hear that name come up too often, but it's worth mentioning just in case you do. So the centroid is the center of mass. Another way of looking at this is if you were to poke a hole right there in the centroid and say hang this thing from the ceiling, it would hang nice and flat. It's not going to tilt one way or the other because it'll be balanced as far as how much mass is on either side. Alright, so there you have the centroid. It's the meeting place of the medians of the triangle, a median being a line from the vertex to the midpoint of the opposite side, and it is the center of mass of the triangle. So it's the balancing point of that and divides the triangle into 6 equal parts. Alright, one more interesting property of the centroid is that if I were to take a single median, so we've got all of this right here, and let's strip that back so we're just focused on one, and we leave the centroid drawn in there. That centroid now divides this median up in a characteristic way, and let's put some labels on this so that we know what we're talking about. We'll call the vertex of this A, and then we'll call the centroid itself B, and then the midpoint will be C. What happens here is that centroid divides up the median so that AB is twice as long as BC, and we can put some numbers with it if you want to. Let's say BC is 5 inches, well AB would be twice as long, so that would be 10 inches. And this is always going to be true. The centroid will always divide up each median in this characteristic way, such that it comes in 2 parts, and one of them is twice as long as the other. Now it will also work out that the part that is twice as long as the other is always the part between the vertex and the centroid. So from the vertex to the centroid will be twice as far as from the centroid to the midpoint of the triangle.